friends, welcome to another edition of this program. I am Adika Solomon. Today we'll be dealing with exponential equation. But before we continue, don't forget to subscribe to my YouTube channel, Adika Mathematical Solution, and follow me on Facebook and Instagram for more updates. Please don't forget to subscribe. Thank you. Today, as I earlier said, we'll be looking at exponential equations. And here we focus on the examples where we have three. Example one, we have 3 raised to the power of x is equals to 2, 4, 3. And this one, all these are the examples. Then we move straight to the solution. And here we say solution. Solution 1, 3 raised to the power of x is equals to 2, 4, 3. And here when we have 3, 2, 4, 3, for us to get the values, we say 3 raised to the power of x is equals to 3 raised to the power of 5. And most of you will be wondering why is 3 raised to the power of 5. You see 3 times 3 times 3 in 5 places, it will get this. The simplest way to get it, you say 2, 4, 3. If you say you look for a value, the smallest value that will go into this value without remainder. And when you say 2 cannot go into this without remainder. So we try 3 and 3 can go into it. Then we say into 3 into 2. 3 cannot go into 2. So you add the 2 here. You say 3 into 24, it will be 8 times. And 3 into 3, it will be 1. And here we can say 3 again. And 3 can go into 8. How many times? 2 times remainder 2. So here you can go 2 times and remainder 2. So these two, when added, become 21. And 3 can go into 21 7 times. You can say 3 can go here. How many times? 3 can go into 2. You cannot go into 2. Then you can go here. How many times? 9 times. Then 3 can go into 9. How many times? 3 times. And 3 can go into 3 1. That is 1 2 3 4 5. That's why we have 3 raised to the power of 5 here. And when you divide 2 by 3, 2 by 3, then the 3 will cancel itself and our x will be equals to 5. Then solution 2, we have 5 raised to the power of x plus 1 is equals to 1 over 6 to 5. And here 6 to 5 is the same thing as is equals to, that is x plus 1 is equals to 1 over 5 raised to the power of 4. And when you try the same method which I tried there, you can say the smallest value that can go into this without remainder is 5. And when you try this, you get this. So 3 into the 5 into this value to give you 5 raised to the power of 4. So from here we have 5 raised to the power of x plus 1 is equals to, since using the applying the law of indices as I earlier said in my other video. If you have not watched the video, please check the video on laws of indices. And here it will become 5 raised to the power of negative 4. So here we divide through by 5, and here our x will be, our x plus 1 will be equals to negative 4. And here our x will be equals to negative 4, negative 1. It's negative 1 because when you are collecting like terms, you take this positive 1 to the other side, and when you are taking the positive side and it's crossing the equality sign, it changes to negative. So here it becomes negative 1, and our x will be equals to negative 5. And when we move to the next example, which is example 3, here we have example 3, we have 2 raised to the power of 2x plus 1 minus 33 into 2 raised to the power of x minus 8 is equals to 0. And here when we have this still applying the law of indices, when we have 2 raised to the power of 2x plus 1 minus 33 into 2 raised to the power of x minus 8 equals to this. And here the simplest way to simplify this, we have 2, here is 2 raised to the power of 2x and 2 raised to the power of 1. In the law of indices, when you multiply and we have the same base, you add the power. So when you add the power, you arrive at this. Then minus 33 into 2 raised to the power of x minus 8 equals to 0. And here we have, since this 2 raised to the power of 1 is the same thing as that value, so here now it will be 2 into 2 raised to the power of 2x minus 33 into 2 raised to the power of x minus 8 is equals to 0. So when we have this, you can still simplify this by saying 2 into 2 raised to the power of x or squared. In the law of indices, when you multiply this, they can still have the same value. So minus 33 into 2 raised to the power of x minus 8. So from here, we have which is equals to 0. So from here, we say let p equals to 2 raised to the power of x. And anywhere you see 2 raised to the power of x, you substitute and put p. So from here, we have 2 into p, then square minus 33p minus 8 is equals to 0. And, and here we have 2p square minus 33p minus 8 is equals to 0, which tends to quadratic equation. So here which tends to quadratic equation, and you can solve that, or you can watch quadratic equation, how to solve quadratic equation in our um, channel. Okay, so let's move to the next one, which is question number 4. Example 4, which says 3 raised to the power of 2x plus 1 plus 8 into 3x, 3 raised to the power of x minus 3, which is equals to 0. And applying this, we have 3 raised to the power of 2x times 3 raised to the power of 1. When you multiply this, you add the power. Since they have the same base using the law of indices, so it will give you the same thing like this. When you say 3 times 3, you pick 3 and add 2x plus 1, you add the powers, plus 8 into 3 raised to the power of x minus 3 equals to 0. So from here it will become 3 into 3 raised to the power of x all squared. In the law of indices, when you have this, it's the same thing as this. When you multiply this, it will give you this. Then, and anything raised to the power of 1 is still that number. So here it will be 8 into 3 raised to the power of x minus 3 is equals to 0. So from here, we say let q be equals to, you can say let any value a, b, or any you can let any alphabet, as I'm using q, be equals to 3 raised to the power of x. So anywhere I see 3 raised to the power of x, I put this value. So from here we have um, we have 3, since the 3, this is the same thing as q, be this q, then the square here plus 8q minus 3 is equals to 0. So from here, it tends to quadratic equation. Like in the other example, I do not go solve further so that you can solve it, but most people must have been complaining, so this I have to solve it further. And when you have a quadratic equation like this, either use quadratic formula or You use quadratic formula, or you can use normal quadratic, which equation to solve this. Since you have this, you can look for a value. You say this times this. This is A, this is B, and this is your C. And you say this multiply the coefficient of q square multiplied by the constant. And when you multiply it, it gives you negative 9. So here you look at a value that when you add, it gives you negative 9. And when you multiply it, it gives you 8. So from here we say 3q square. And let's try. If you say um, if you say minus 1 plus 9, it will give you this when you say minus 1. And since it's 1q, you can say minus q plus 9 cube minus 3 is equals to 0. That is, here is 9, so you look for a value. When you say minus 1 times positive 9, it will gives you negative 9, and when you add it will give you positive 8. So you look at this. So from here you look for what is common, and here what is common. So from here to solve further, you can say 3, you can say in the common thing here is q. It's q, then you say q here into 3q minus 1. That means when you multiply q by 3q, it will give you 3q square. You multiply q by negative 1, gives you negative q. And here we have plus, let's say 3 into 3q minus 1 is equals to 0. When you multiply this by this, it gives you positive 9q. And when you multiply this by this, it gives you negative 3. So which is equals to 0. From here we pick, when you're solving your quadratic equation, you pick this and this. So you have q plus 3. And one thing about quadratic equation, when you're solving quadratic equation, make sure the ones in the bracket are the same. So we have this q plus 3 is equals to 0, or or 3q plus minus 1 is equals to 0. So from here we say our q plus 3 is equals to 0, or here we say 3q is equals to 1. So from here when you turn this in, you are collecting like terms. This positive 3 will come this side to change to negative. So our q will be equals to negative 3, or our q. Here you divide both by 3 to get only q. So you divide here by 3, here by 3. So our q now will be equals to 1 over 3. But recall that we say let our q be equals to 3 raised to the power of x. So now we substitute, we go back again, we say 3 raised to the power of 3 raised to the power of 3 now will be raised to the power of x will be equals to minus 3, or this one now will be 3 raised to the power of x is equals to 1 over 3. And here you can see our 3 raised to the power of x is here will be 3. This, so when you divide 2 by 3, here we have 3 raised to the power of x is equals to minus 3, or here will be x is equals to minus 1. And from for here we can say this one which has no solution. So this one now has no solution, and here x is equals to minus 1. So without taking much of our time, let's move to another example, which is the final example. And this one we are saying number 5, which says 3 raised to the power of 2x plus 1 minus 4 into 3 raised to the power of x plus 1 is equals to 0. So applying the same method, applying the same method here, we say 3 raised to minus 3 raised to the power of 2x minus 3 raised to the power of 1 minus 4 into 3 raised to the power of x plus 1 is equals to 0. So from here, 3 raised to the power of 1 is the same thing as 3, so it's 3 into 3 raised to the power of x here square minus 4 raised to the power of 3x plus 1 is equals to 0. So from here we say let a be equals to 3 raised to the power of x, and here we substitute here we have 3a square minus 4a plus 1 is equals to 0, and here it turns to quadratic equation again. So here we look for a value. When this one, you multiply this one by this one, it gives you 3, and you look for a value that when you multiply it gives you 3, and when you add to give you 4. So let's try um, negative -1, -3. When you have -1 and -3, when you multiply it gives you +3, and when you add it gives you this. So here we have 3a square negative a, that is -1a, and this is something as a minus 3a plus 1 is equals to 0. So when you do this, you see the same thing here. We are trying to split, and here we look for what is common. You see a, we bring a outside for this one. You say 3a minus 1, and here we look for what is common. You say is what? Here we can say is 1, and is positive 1, is -1. So -1 now it will be into 3a minus 1 is equals to 0. So when you multiply this by this, it gives you this, and multiply this and this, it gives you positive this. So from here we can see our a minus 1 is equals to 0, or 3a minus 1 is equals to 0. So here collecting like terms, this -1 will turn to this, it change to this side, so it turns to +1. So our a will be equals to 1, or 3a is equals to 1. So from here we say our a is equals to 1, or when you divide through now we say our a is equals to 1 over 3. And recall that we say is equals to our a is equals to 3 raised to the power of x. So coming to here now, we say 3 raised to the power of x is equals to 1, or 3 raised to the power of x is equals to 3. And this one, we say 3 raised to the power of x is equals to 1, or here the 3 we cancel itself, and our x is equals to -1. And here 3 raised to the power of x is equals to 1, which has no further solution. So our x is -1. So thank you for watching this section of the lesson. Please don't forget to subscribe to my YouTube channel, Adeka Mathematical Solution, and follow me on Instagram and Facebook, Adeka Mathematical Solution, for more updates. Please support me, support the program. Thank you for watching.